Hello and welcome to the Unified College platform. My name is Yemi and I will be your maths tutor on this platform. Come with me as we experience mathematics in a different dimension on this platform. I can assure you that every bugging issue in mathematics will be well sorted. You're welcome.
Okay, so you are once again welcome to the very first class in mathematics, and I mean the very first class in a function of a function. Okay, our objective for this class is to determine whether a relation represents a function. Now, first of all, what is a relation? A relation is a set of ordered pairs where the first set is called the domain, while the second set is called the range. An example of a relation is as shown. Okay, now there's something in relation which maps. Okay, now if you have 1, 2, 3, 4, 5. Okay, you have 1 maps to 1. Okay, as you can see in this relation. Okay, your 2 maps to 4. Okay, and so on. Your 3 maps to 6. Okay, your 4 maps to 8, while your 5 maps to 10. Okay, so this is a relation where the first set is called the domain, while the second set is called the range. Okay, now don't forget also that this relation, as you can see, is comparable to a relation in x and y. Okay, like let me give you an example. If you refer to each of these sets as a relation in x, x comma y. Okay, if we say this one is x1, this is y1, then x2, y2, comma y2, then x3, comma y3, and so on and so forth until you get to x infinity, comma y infinity. Okay, so this is your set of domain, while this is your set of range. Now don't forget that the domain is also referred to as the input. Okay, now if you have a relation in mathematics, the domain is usually referred to as the input or the independent variable, and then the domain is usually referred to as the x in your equation in mathematics. Okay, also the range is referred to as the output of your relation, the dependent variable, and it is denoted by y. Next, what is a function? Now, a function, usually represented by this letter f, is a relation that assigns a single value in the range to each value in the domain. Like as you see in the previous illustration, Now, note, okay, let's emphasize this aspect. You are to note that no x values must be repeated. Okay, that is telling you that if a relation must become a function, then no x values must, as a matter of must, be repeated. Domain or input or independent variable. Okay, say note, no x values must be repeated, that is the domain or the input or the independent variable. Those are also references to x. Also, a function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. Okay, now note, the output is usually a function of the input. The input value make up the domain, don't forget that, and the output values also make up the range, as you can see on your screen. Now, let's look at in this example, in this relation. Let's look at this. So for our example that relates the first 5 natural numbers to double their values, this relation is a function because each element in the domain, that is 1, 2 to 3, 2 to 5, is paired with exactly one element in the range, which are 2, 4, 6, 8, 10, as shown below. Okay, now this is a relation. Now this relation is a function because each of these domains are unique, that is, none of them is repeated. Okay, note the word unique. When I say something is unique, I mean none is repeated. None is repeated. Okay, take note of this. When I say a group of elements are unique, what I mean is that none of them is repeated. Now also, if you look at the range, all of them as well are unique. Now let's look at some examples that will help us to confirm if a relation is actually a function. Okay, now our title for this part is determining whether a relation or a relationship represents a function. Example A is showing input PQR mapping to output MN. Okay, now as you can see that each of these inputs are unique, none of them is repeated. Okay, it doesn't matter if the output is repeated. All we are concerned with is that the inputs, each and every one of them, are unique. Okay, as you can see here, P maps to M, Q maps to N, and R also maps to N. Okay, now because all the inputs are unique, we conclude that this relation is a function. Let's look at example B. we have inputs PQR and we have outputs XYZ. As you can see, all the inputs are unique. The outputs also are unique as well. Okay? None of the inputs and the outputs are repeated. Each are unique and distinct. As you can see, unlike in the previous example, the inputs are unique, but the inputs are unique and distinct, but the outputs are unique, but they are not distinct. For our example B, both the input and the output are unique and distinct. Hence, we conclude that this is a relation. Finally, in our third example, we can see that the inputs are not unique, but they are distinct. While for the output, all of them are unique and distinct. Okay, now this is against the rule in that Q as an input is producing two different outputs. It produces output Y at the same time produces output Z. Okay, since this is against the rule, then this relation is not a function. Next, let's look at how to determine whether the general rules to observe in determining whether a relation is a function. Okay, we given a relationship between two quantities, determine whether the relationship is a function. Now, the first thing to do is to identify the input values. Then secondly, you identify the output values. Then finally, compare. If each input value leads to only one output value, classify the relationship as a function. If any input value leads to two or more output values, do not classify the relationship as a function. Okay, now let's look at example 1. The question says determining if many price lists are functions. The coffee shop menu shown in the figure below consists of items and their prices. Question A says, is price a function of item? Is price a function of the item? While question B says, is the item a function of price? Now, in solving the first question, is price a function of the item? Now, don't forget that your output is usually a function of the input. Your output is usually a function of the input. Okay, for our example, our output is price, while our input are the item. Okay, now looking at all these items, we can see that each and every one of them are unique. In other words, let me put it here. Our item, these are the inputs, while our price is the output. Okay, now the plain donuts, the jelly donuts, the chocolate donuts, all of them are unique and they map to certain prices. Okay, now just by looking at all these inputs as unique, we can conclude that question 1 is true. Okay, now question 2 says, is the item a function of price? Okay, how do we do this? It's better you do it this way. Rearrange it, put your price at the input level and put your item as the output. Okay, if you have done that properly, you are going to have, let's say this is our price, okay, and these are our items. Okay, now for the first item, which is jelly donuts, let's see, okay, plain donuts, jelly donuts. Our first item here is plain donuts. Our second item is jelly donuts, while the third item is chocolate donuts. Now the price for the plain donut is 1.49. The price for the jelly donut is 1.99, and the price for the chocolate donut is 1.99. Okay. Now we said here we have our outputs, and here we have our input. The input, don't forget, the output is usually a function of the input. Now, what you need to determine, to answer the question, is the item a function of price, is to look at the inputs. Are all of them unique? As you can see, your input is unique only if none of them is repeated. But unfortunately, you can see the price for jelly donuts and chocolate donuts, they are repeated. So this is never a function. Hence, our answer to question 2 is the item a function of price? Is false. Example 2. Now, the question says, in a particular class, math class, the overall percentage grade corresponds to a grade point average. If the grade point average is a function of the percent grade, then is the percent grade a function of the grade point average? Okay, let me do some correction here. We take this as our first question. Here is, and then question A. We take this as our second question, question B. Is the grade point average a function of the percent grade? Is the percent grade a function of the grade point average? Now, to answer the first question A, is the grade point average a function of the percent grade? Okay, never forget that your output is usually a function of the input. Output is usually a function of the input. Okay, so the question says, is the grade point average, that means the grade point average in the first question is our output. This is is our output. Okay, while the percent grade is our input. Okay, now the rule is that your input must be unique. Now, looking at the percent grade, you can see that 0 to 56% maps to a grade point average of 0. 57% grade to 61 maps to a grade point average of 1, and so on and so forth. Okay, now this means if a certain student has a percent grade of 92, for instance, the grade point average of such a student is 4.0. Now, if another student has a percent grade of 100, or let's say 99, the grade point average of such a student is also 4.0. So we can see that our input has been repeated for the same value of output. Hence, the first question, is the grade point average a function of the percent grade, is false. To answer the second question, B, is the percent grade a function of the grade point average? Okay, don't forget that the output is usually a function of the input. Is the percent grade? Percent grade here is our output. So let's change this to our output. The percent grade, our output, and the grade point average, our input. Now, looking at all the inputs, they are unique in that none of them is repeated. Okay, 0 maps to 0 to 56, 1 maps to 51 to 61. Okay, all of them are not repeated. Hence, we say that question B, which says, is the grade point average a function of a percent grade, is actually very true. Now, summarily, this question says that which of the following represents a function? Okay, let's look at these three functions. Let's label this one A, label this B, label this C. Okay, which of the following represents a function? Now, the idea in this question is to watch out for an input that is repeated. As you can see here, this is our input of X values, while this is our output or Y value. This is X input, this is Y output. This is X input, this is Y output. Now you have your F representing whether it's a function or not a function. Now, if you observe all the X values here, you notice that all of them are unique in that none of them is repeated. They are unique and distinct, and the outputs also are very unique and distinct. Unique and distinct. Okay, hence this is a function. So if you look at the second example, where you have 6 mapping to -5, 7 mapping to 8, 9 mapping to -2, 3 mapping to -2 again, and 2 mapping to 4. Now, the our concern is the input, which are the x values. Okay, looking at all the x values, all of them are unique and distinct. Okay, but not minding these two values, which are the output values of 9 and 3. Both of them are the same, but it doesn't affect our judgment that this relation is actually a function. Okay, finally, you look at the x values, which are the input values here. We notice that 3 is repeated, producing different outputs in -4 and -8. This actually breaks the rule. Okay, this breaks the rule, and hence it is not acceptable. Watch out for the input. The idea is to watch out for the input. None of the input values must be repeated. All of them must be unique and distinct. And in this scenario, it is not so. Hence, our judgment will be that this is never a relation. I believe that following through this lecture, you come to terms with me that a relation, you'll be able to, when you see any question asking you whether a relation is a function, outrightly you'll be able to tell that this relation is a function, this other relation is a function, and this is not a function. Thank you for being a wonderful audience. I'll see you in the next lesson. Bye.